In the previous movie, we set up the basic hand joints and FK controls. In this movie, we're going to create some custom attributes that will make compound finger movements easier. Start by opening the file Character Rigging, Part 29 Start, or by using your own file from the previous lesson. While our current setup would actually allow us to animate the hand poses as is, it's not the easiest setup to work with. A simple motion like curling one finger would require keyframing 3 different joints. To simplify an animator's workflow, we're going to create a control curve for each finger and use custom attributes to drive some of these common compound motions. Hide the hand's FK layer. We first need an actual control to assign our compound finger controls to. Let's use a standard NURB circle to keep things simple. Position it above the palm, in line with the pointer finger, and rotate it 90 degrees in the Z-axis so it faces out. Rename it Left Pointer Control. Assign it to a new layer called Hands Compound Control Layer. It's not really an FK or IK control, so set its color to red. The first attribute we'll add will be to curl the finger towards the palm. Create a curl attribute on the left pointer control. Set its minimum to -10 and maximum to 10. We're going to use this attribute to drive a key on the pointer joint chain. However, we don't want to connect it to the FK control chain, otherwise we won't be able to manually adjust them anymore. This is the reason we created the orient joints in the previous movie. Rename the orient joints on the control hand with a compound control joint identifier. Also rename each finger's base joint with this identifier as well. Now open the set-driven key window. Load the left pointer control as the driver and all its compound control joints except the last one as driven. Set a key between the driver's curl and the driven's rotate Z attributes. Now set the curl value to 10 and rotate all the orient joints so the finger is fully curled. You can start at a value of 90 and then tweak the second and third compound control joints to push the pose a little further. You should also rotate the base joint just slightly to create a subtle sense of knuckle compression. Set another key. Now you can curl the entire finger by adjusting this one attribute. But if you turn on the hand's FK layer, you can still use the FK controls to make small adjustments to the finger. To set the negative curl, hyperextend the finger like so. Next, we'll create a scrunch attribute. Give it the same minimum and maximum values. A scrunch will use everything except the base joint, so set a new driven key using their default Z rotation values. Set scrunch to 10, Then position the finger's compound control joints like so. If you view the scene from the side view, the fingertip should fall roughly in line with the base of the palm. Since a scrunch compresses the fingers inward, then a negative scrunch should hyperextend it very slightly, like this. Next, we'll add a lean attribute to lean the finger sideways in the y-axis. Like the scrunch attribute, a lean doesn't need to make use of the base joint. Finally, we'll add a relax attribute. This one will have a minimum of 0, since there isn't really a concept of negative relaxing. A relax is similar to a curl, except notice that each joint rotates less as you move down the finger. Now that we have one completed finger control set up, duplicate it over the remaining fingers and set driven keys for them as well. We've included a scene file along with this lesson where this is already done for you. Once the controls for the individual fingers are set up, we'll next want to add a control that manipulates all the fingers at once. For this, we'll duplicate one of the finger controls, rename it Left Hand Control, and fashion an oval from it using its control vertices. We'll use its custom attributes to affect all the fingers at once. Unfortunately, we can't just connect these attributes to their single finger counterparts, as it would leave them unkeyable for animation. Instead, we'll have to recreate the finger positions once again using a new set of driven keys. As before, we've included a scene file below where this is already completed. Notice during a relax how all the fingers are all relaxed slightly different amounts, like they typically are when you relax your real hand. We've also keyed the fingers in a negative relaxed pose, which is essentially the relaxed pose, but with reverse finger order. This can make things like tapping our fingers on a table a little easier. In addition to these, we'll add a couple more controls. First, a spread attribute, with a minimum of -10 and a maximum of 10. This will allow the animator to spread the fingers apart or squeeze them together. Load each finger's base and first compound control joints as driven. Set a key between the spread attribute and these joints' rotate Y attributes. Then at a value of 10, spread them out like so and set another key. At a value of -10, squeeze them together like so, then set another key. Next, we'll add a fist attribute with a minimum value of 0 and a maximum of 10. For this, we'll need to load all our compound control joints, including the thumb's orbit joint. Set a key between the fist attribute and all the compound control joint's rotate Z attributes. However, for the orbit joint, we'll need to key all the rotation values. At a value of 10, curl the fingers like you would for the curl attribute. However, for the thumb, we'll also use the orbit compound control to position it under the other fingers to form a fist. There. Now you can use the compound finger controls to get a pose close to what you want, and then use the FK controls to tweak them more precisely. As one final cleanup exercise, select all the compound control joints and open the graph editor. Set all the tangents to linear. This will keep the joint movement consistent over the entire range of the controls. Now your finger controls are set up. As an exercise, why not try posing the fingers in the following ways? In the next movie, we'll set up the palm controls.